do the tutorial for the air conditioning process. But before that, please let me know what is the current status for this class. You have Dr. Wan has covered until what section?
Kelas
Rasa
itu saya miss sebab
Tak dengar lah.
sampai a diabetic mixing chambers.
Oh, adiabatic mixing chamber. Okay,
Uh-uh.
good. And then he has shown about the psychometric chart. Semua dah tengok? The processes through the psychometric chart. Dah ada ya? Okay, good. So which is actually the psychometric chart can be applied for the when the condition of the apa nama tu, slide saya dah nampak
nampak sir.
Okay. So the psychometric chart can be applied when the condition is at 1 atmospheric pressure. Okay, when the atmospheric pressure is equal to standard atmospheric pressure, which is 101.325 kilopascal. Okay, so through this psychometric chart, kalau kita ambil from this psychometric chart, if you want to remember easily, okay, so what we have here, this is a specific humidity omega, and then kat bahagian bawah ni, this is a dry bulb temperature, and then bahagian untuk this side you have the enthalpy, and then yang this line, you can see this is the relative humidity. Okay, so from this psychometric chart, moving to the left, okay, moving to the left is the cooling process. Okay, moving to the right is the heating process. So let's say that if you are at 25 degrees Celsius, if you are going to heat to 35 degrees Celsius, that is a heating process. Okay, simple heating. And then moving to the left is the simple cooling. Okay, up, which is increasing the specific humidity. Okay, so okay, up is the increasing the specific humidity. Okay, so which is the humidifying process. Okay, when you go down from this point, you are dehumidifying process. Okay, and then as well, if you are involving two processes, which is the heating plus with the humidifying, so you move apa ni, kalau kita ambil compass, this is north, this is the north, this is east, yeah, this is east, northeast, which is heating and humidifying. Okay, and then this is the south, kalau kita ambil compass, and this is going to be a cooling and dehumidifying, where it involving with the two processes. Okay, so when we translate it into the engineering perspective, okay, in the simple heating, whereby you have the inlet temperature T1, kenapa tak lagi ni, T1, omega 1 and Phi1, ada ni ada timing animation, mana ni animation dia, slideshow, tak ada, yeah. So so when you have the simple heating, as you can see here, slide saya gerak ni, animation, mana nak off this animation ni, aduh hai, animation, ada animation, mananya, Ada pula kat sini ya. Ini ada appearance. Apa? Okay. So when you have here the simple heating, which is, as you can see that the T1, the temperature will be increased. Temperature will change from T1 to T2, but the relative, the specific humidity will be remain. But however, the relative humidity is changes. So when the increase of the temperature, the relative humidity will be decreased. But for the simple cooling, the temperature will be decreased. However, and the specific humidity is constant. However, the relative humidity will be increased. Okay. And then this is two processes involved, which is the heating with the humidifying, where through the heating coil, heating section, the specific humidity is remain, the temperature is increased, and in the second section, in the humidifier section, the specific humidity will be increased, and as well the temperature will be increased too. And then in the cooling with the dehumidifying, the temperature from the T1 until T2, so the temperature will be decreased, and then throughout the cooling section until it is achieved to the apa kita panggil sebagai, if you have the psychromatic chart, okay, here the temperature cooling section sampailah kepada V equal to 100, itu the saturated conditions, okay, from the temperature T1, and then throughout this saturated condition, temperature will be decreased and it will follow the saturated line, and then from here the omega 1 will be decreased to omega 2 because this is condensation will occurs, and then it until it achieves to the T2 section. So where the T2 is less than the T1. However, in this condition, the omega will be decreased, and then as well, the relative humidity will be higher than the relative humidity at the T1. Kerana apa relative humidity ni? Because in this condition, it is already in the saturated condition, in the saturated line, which is relative humidity equal to 100%. Okay. All right. So let's go to the tutorial today that I'm going to present some of the example where the first section, which is actually we're going to use with the psychometric chart, and in the second part we're going to use with the apa kita nak pakai, kita akan pakai the condition that you cannot use the psychometric chart, whereby you have to derive all the required required variables. Okay, that variables apa the temperature variables and the parameters. Okay, the variable kat sini adalah the temperature, the pressure, and then the apa nama lagi, the temperature, and then the parameters is the relative humidity, the specific humidity, another variables, enthalpy. Okay, so if you are using the psychometric chart, these variables and parameters, you just get it from the psychometric chart like this. Yeah, this is the psychometric chart. So you just point that location on the psychometric chart, and then find what will be the variables and parameters from this psychometric chart. However, if you are not using, if the pressure is more than or not equal to 1 atmospheric pressure, that you cannot use the psychometric chart, then you have to do the theoretical calculations. Okay. For this example, air at 1 atmosphere, 15 degrees Celsius, 60% of relative humidity. Kalau kita and at 45 meter cube per minute is first heated to 20 degrees Celsius in a heating section, then humidified by introducing the water vapor. So the air leaves the humidifying section at 25 degrees Celsius and 65% relative humidity. Determine the amount of steam added to the air. So the amount of the heat transfer to the air in the heating section. So this is process of heating with the humidifying. So if we draw the schematic diagram, so this is a first section and this is a second section. Or we can say that this is a section A, this is a section B, where this is a state 1 inlet, state 2 exit, where the state A is the heating section. Process for B is the humidifying. Okay, and then you pergi pada state 3. So in this first section, which is the heating. So in the heating, there will be the Q in to the system. And then in the humidifying section, where you have the humidifier. Okay, so in this humidifier, there will be a steam injected. Where steam is injected, dia tak bagi tahu. So we assume that steam is 100 degrees Celsius. Okay, so Tg is equal to 100 degrees Celsius, where we don't know what will be the m dot g. Okay, so the here in this first section, air inlet at temperature T1, which is equal to 15 degrees Celsius. Relative humidity is 60%, and the V1 is equal to 45 meter cube per minute. So which is you have to convert it into the kilogram per seconds. Okay, and then it's heated to 20 degrees Celsius in the heating section. So T2 equal to 20 degrees Celsius. Okay, and then humidified by introducing the water vapor. The air leaves the humidifying section at 25 degrees Celsius and 65%. Okay, so T3 equal to 25 degrees Celsius, V3 equal to 65%. Okay, so that's all the information that we have. And then you have to draw the schematic diagram. And then let's look on the psychromatic chart. Tadi dia kata in that section, T1 is 15 degrees Celsius and 60%. This is a 15 degrees Celsius, relative humidity 60%. Okay, so this is a T1. So from this T1, you can read apa dia? The T1 dry bulb temperature, and then you unjurkan kat sini, then you can read omega 1, which is omega 1 is equal to berapa tu? 6 point, atas tu berapa tu? 8, and this is 6. Berapa sangat dia ni? 1, 2, 3, 4. Oh, 5 ya satu ni. So this is a omega 1 equal to 6.5 gram of moisture per kilogram of air, dry air. Okay, kilogram of dry air. Okay, so yang tu kena tulis ya, please write down. Which is okay, T1 so T1 state 1 T1 is equal to 15 degrees Celsius, P1 60%, omega 1 berapa omega 1 tadi? 6.5 gram per kilogram of dry air. And then lagi dekat you punya ni. Are you following me?
Yes, sir.
Okay,
Yes.
so you tarik kat sini that you can see this is a 3.2. Sorry, 32. The enthalpy is H1 equal to 32 kilojoule per kilogram of dry air. And then okay, so then this is volume cubic meter per kilogram of dry air. Okay, so you boleh pakai yang this value. So yang ini adalah this is the volume cubic meter. Okay, zero berapa ni nilai dia? 0.82, 0.83. So it is about 0.8 berapa ni? 85 tak sampai 0.82 0.825 untuk apa tu? Untuk volume per cubic meter. This is the specific volume. Okay, this is a specific volume. Specific volume I put just S ya. S1 specific volume, tapi bukan, this is not entropy ya. 0.825 meter cube per kilogram of dry air. Okay, kilogram of dry air. So from this state 1, which is actually you can calculate the mass flow rate. Okay, which is the mass flow rate. The mass flow rate m dot is equal to rho A V, which is also equal to Q dot kali dengan apa? Q dot kali dengan rho is rho AV ya, Q dot kali dengan rho. Yep, Q dot kali dengan rho. Q dot bukan kali dengan rho. Q dot yeah. So this is a volume cubic meter per kilogram of dry air. Okay, so this is apa ni? This is volume cubic. Yeah, this is volume cubic. So this is equal to this is, oh yeah, betul lah. So this is equal to where rho is equal to, unit dia adalah apa? Rho is kilogram per m cube kan? So S is inverse of the rho. So what we have here is that m dot 1 is equal to Q dot bahagi dengan S. So what we have here 60 apa nama tu, you punya Q dot 1 is equal to 45 meter cube per minute. Okay, so what you have here is that here, so the mass flow rate MA1, okay, MA1 is equal to 45 0.45 meter cube per minute darab dengan 1 minit over 60 second darab dengan rho which is 1 over S, which is oh ya, betul. 0.825 oh, tak perlu dah ni. This is tak, M cube. Okay. 0.825. Saya nak tulis unit kat sini tak cukup ruang. So what you have here, which is this is the mass flow rate, tapi besar sangatlah. 0.4. Cuba kira kejap. 45 divided by 60 and then times this is not time. This is 0.825. Cuba kira kejap berapa tu nilai dia? Cuba kira kejap.
0.909.
Oh, 0.909 Yeah. So the value is reasonable.
0.0909.
0.909
909.
0.909 ya. 0.909 kilogram per seconds. Okay, 0.909 kilogram per second. So that's the value for the MA1. Okay. All right. So now at the state 2, T2 is equal to 20 degrees Celsius kan? Okay, so T2 is 20 degrees Celsius. And then omega 1 is equal to omega 2. Kenapa omega 1 is equal to omega 2? So before we go omega 1 equal to omega 2, which is actually you have to do the energy balance and mass balance. Mass balance, we do the mass balance dulu. Okay, we do the mass balance. So mass balance, summation of mass for the dry air, summation of mass inlet equal to summation of mass A outlet. Okay, so mass yang masuk untuk inlet, which is M dot A1. Ada lagi yang lain? Tak ada kan? Kat dalam you punya sistem ni, yang sini je M dot A1. This is antara 1 kepada 2. Okay, so this is a QE. So what you have is M dot A1 is equal to M dot A2. And then for the moisture, summation of mass for the moisture equal to in summation of mass moisture out. Okay. So daripada di sistem humidifier duduk sebelah sana. So antara 1 and 2. Okay, so what you have? M dot V1 equal to M dot V2. Whereby M dot V1 sama dengan omega 1 M dot A1 kan? Dr. Wan dah tunjuk baru ni kan? Equal to omega 2 M dot A2. But M dot A1 is equal to M dot A2. So thus omega 1 is equal to omega 2. Okay, so omega 1 dah dapat tadi. So omega 2 which is equal to 6.5 gram per kilogram of dry air. Okay, so omega 1 omega 2 dah ada. V2 tak tahu lagi. So V2 you kena dapatkan daripada equation lah. Ataupun you V2 ni you boleh dapat, V2 ni you boleh ambil, oh ni tak cukup. Okay. Tambah lagi. So this V2 you boleh baca terus daripada sistem. Saya memang suka buat yang derivation ya, berbanding dengan psychometric chart. So V2 tadi sampai 20 degree Celsius kan? So 20 degree Celsius. So V1 sampai V2 sampai sinilah. Okay. So you can read it from the psychometric chart. Boleh baca psychometric chart berapa nilai. This is a T2. Berapa nilai untuk you punya H2. So this is a H1. This nilai untuk H2 which is about 37. Okay, H2 sama dengan 37 kilojoule per kilogram of dry air. And then V2 will be reduced. Berapa ni V2 ni? Kalau you tengok nilai dia antara 40 dengan 50. So this is about I think this is about, clearkan sikit. Okay. So, okay, so this is going to be nilai dia. Kalau you pakai kertas lagi better ya, sebab dia boleh apa nama tu project dia dengan pembaris ya. And then this one nilai dia lebih kurang, I think this is about 43%. V2 sama dengan 43%. Okay. So V2 is equal to 43%. V2 equal to 43%. H2 sama dengan 37 kilojoule per kilogram. Okay. Alright, so what else? Kita nak kena kira dapatkan di energy balance. Okay. Energy balance antara process 1 to process 2. So what we have here, summation of energy in equal to summation of energy out. Okay. Sekejap ya, tengok sama ada orang yang di meeting person nak sampai. Okay, which is energy in equal to energy out. M dot A1 H1 energy in Q dot in equal to M dot A2 H2. Okay, so M dot A1 is equal to M dot A2. H1 tadi dah ada, H2 pun dah ada. So what we have is amount of heat in which is equal to M dot A kali dengan H2 tolak dengan H1, which is M dot A berapa tadi? 0.909 ya. 0.909 kilogram per second. H2 37 minus 32 kilojoule per kilogram of dry air. Okay. So dapatkanlah nilai Q in ya. Berapa? Boleh tolong kira kan?
Um, 4.545.
4.545 kilowatt ya. So that will be the heater capacity to heat up 0.909 kilogram per second of the air into the system. Daripada naik to increase from 15 degree Celsius to 20 degree Celsius. And then we have to look for the process 2 to 3 where this is the humidifying process. Okay, so through this humidifying process there will be a humidifier yang masuk dengan M dot G, which is we assume equal to 100 degree Celsius from state 2 to state 3. Okay, so this is the humidifier, and then we need to determine how much the mass flow rate for the humidifier untuk naik daripada T2 equal to 20 degree Celsius. V2 berapa tadi? V2 43 ya. Omega 2 sama dengan 6.5 gram per kilogram of dry air. Untuk pergi ke berapa nilai dia? to increase sampai berapa tadi? 25 and 65% of the relative humidity. Okay. So T3 equal to 25 degrees Celsius. V3 equal to 65%. So kalau you tengok dekat Psychometric chart, if you refer to the Psychometric chart, 65% is here around this line, 25% is this point. Okay, so what you have, naik daripada sini ke atas. Okay, so from here, so this will be the state 3. So state 3 kalau you unjuk, you boleh dapatkan bacaan untuk this one, omega 3. Berapa tu omega 3 tu kalau you tengok daripada this 12.5, 13.5, okay, 13.5 gram per kilogram of dry air. Enthalpy dia berapa? Enthalpy dia kalau you tengok daripada this one, it is about 60 kilojoule per kilogram of dry air. Ingat ya? So this is a H3. So nanti please print this psychrometric chart. Okay. So from the psychrometric chart, H3 is equal to Allah Akbar 70 Nah, 60 dengan 13.5. 60 kilojoule per kilogram of dry air, and omega 3 is equal to omega 3
13.5
13.5 gram per kilogram of dry air. Okay, so we have to do apa dia untuk dapatkan nilai m.g ni? Kita kena tengok mass balance ke energy balance. Mass balance or energy balance?
Mass balance.
Mass balance ya. Mass balance untuk dry air ke moisture?
Moisture.
Moisture. Good. So we have to look on the mass balance for the moisture. Sebab dry air dia tidak ada penambahan. Okay. So we have to look at the mass balance for the moisture. Okay. So which is mass balance for the moisture? M.V2. Ada yang kemasukan. So masuk dia sini kan. Plus M.G equal to M.V3. Okay. Yang mana M.V2 is equal to omega 2 M.A2 plus M.G yang masuk daripada humidifier equal to omega 3 M.A3, where M.A3 sama dengan M.A2 which is equal to M.A. M.A adalah constants. Okay. From here, M.A tadi bersama dengan berapa? 0.909.
909.
Ya, kilogram per second. Omega 6.5. 6.5 tadi ya, 6.5 kilogram per kilogram of dry air. You kena tukar ni. Sebab this is a gram so kena bahagi dengan 1000. Equal to, tambah ya. M.G equal to 0.909 kilogram per second. (13.5 gram per kilogram of dry air). Darab dengan 1/1000. Okay. Yang ni sebab saya nak balancekan you punya unit 1/1000 ni maksudnya 1 kilogram sama dengan 1000 gram. Okay. Nanti you tukar balik lah the value. Okay. Ni pun sama. 1 kilogram sama dengan 1000 gram. Ya. Yeah? Alright. So berapa tu nilai M.G? Tolong kira. So M.G is equal to berapa? Which is sebenarnya 0.909 kilogram per second. 13.5 minus 6.5 gram per kilogram of dry air kali dengan 1/1000. Okay. So dapatlah nilai dia. Okay. 13 tolak 6.5 berapa? 7 7 0.0504 jadi 0.0054 something like that. Betul tak?
0.00636.
Okey, 0.00636 kilogram per second. This is of steam lah. So kalau you ambil, so this is equal to, which is equal to 6.36 gram per second. So this is a mass flow rate of the injected steam. Okay. Boleh? So if you look into this equation balik, into this problem, soalannya, okay, steam added tu berapa, the amount heat transfer. Yeah, so everything is there. Okay. Sekarang pukul berapa? Nak pukul 10 dah. I have to go. Saya ada meeting pukul 10 nanti. So any question? Yang ini kita tengok minggu depan dah. Okay. I think this one kita buat terus dengan apa nama tu? Adiabatic mixing. Okay, adiabatic mixing. Yeah. And then assignment, dalam ni ada assignment. Yeah, assignment 1. And this is the assignment 2. Okay. Dia due date-nya adalah 20 hari bulan 1. Yeah. 20 of January. Okay. So, any questions? Ada soalan?
So far macam tak ada, Doktor.
Okay. So I believe Dr. Wan Ahmad Najmi have given you a very clear presentation dalam kelas dia kan?
Yeah.
So dia ada tunjuk example tak?
Ada?
Example sama ke dengan saya ke lain?
Macam lain.
Lain Okay, good. So you have the varieties of the input to enhance you punya understanding lah. Okay. Alright. So 9:45 tak apa. Saya kena tunggu orang juga nak datang ni. Okay, so any question nanti you boleh throw dalam kita punya WhatsApp group. Please go through the YouTube videos that I have prepared. And then as well the from my previous class, last semester punya class, and then as well this semester punya class, which was given by Dr. Wan Ahmad Najmi. Kalau tak faham, you review balik. Kalau if you have any question, you boleh tanya dalam group. Yeah. Okay. So ada soalan? Tak ada? We can dismiss. Tak ada Eva tak ada? Khairul Fitri tak ada? Syuhada?
Tak ada, sir.
Okay, good. Hari ni berapa orang kelas kita yang masuk ni? 21 orang. Okay. Alright. Cool. Alright. So you have any problem, please let me know. Okay. Bye-bye. Thank you very much.
Thank you, sir.
Thank you, Doktor.
Thank you, sir.
Thank you, Doctor.
Thank you, Doctor.
Thank you, sir.
Alright.